Let's just wait a while and see what the obstacle manager spawns next. Another tiny one, a single one. So I think we're good. I think it's working. It's just that the distance, the random distance, is obviously way off. There we go, another tiny one, a single one. I guess it's working. Let's just go back into the obstacle manager and play with those values here. Oops, that's the ground manager. Here, obviously those values are way out of proportion. So let's say maybe the minimum distance between obstacles in pixels. 100 is quite a bit, isn't it? So let's say maybe 60, and 500 obviously is way too much. So let's say maybe 200. So I've been thinking, I've been treating these values like they're pixels, but I think these are just score points. So let's just say 100 is the maximum and the minimum is 10. I was thinking in terms of pixels, but those aren't pixels, those are points. Still way off, but much better. So go back into the, first off, go back into the T-Rex class here and set, oops. Oh, and set the initial start speed to something like maybe 280. And then go back to the obstacle manager class and reduce the minimum a little bit. Let's say 5. And I guess 50 was okay. And let's test it with the current speed and then increase the speed a little bit just to make sure that at higher speeds it works as well. Here. I guess maybe the minimum distance also has to kind of factor in the speed at which we're currently running, so that it gives us enough space between the individual obstacles. So I guess we're actually okay using this approach here, but we need to also factor in the speed at which we're going and scale the minimum distance by that. Say maybe so there will definitely be a maximum speed that the T-Rex can run at, right? So let's go here into the T-Rex class. And first of all, let's make the start speed constant public. let's remove this multiplication here. And let's define another constant, which is also public, and it will be called max speed. And let's see, what could be the maximum speed? We saw that multiplying the start speed by 3 was already pretty fast. Let me go ahead and check that again. So now we can ignore the gaps between the obstacles. All we care for now is the actual speed. And I think this is already pretty fast. So that would be 840. 280 by 3 is 840. Let's say the maximum speed is 800 for now. And let's say, let's go back into the obstacle manager. And here what we're going to do is say, give a tolerance value, and this value must be the maximum tolerance value. So let's go with 10. 10 is fine. And what we're going to do is we're going to interpolate this value, or basically scale this value by the current speed. So let's go ahead here and when we set the target distance, we actually also need to go ahead and say, get the T-Rex's current speed and divide it by the T-Rex's max speed, and then multiply that by this tolerance value. So that means if the T-Rex has reached its maximum speed, this here will return 1. And then we're going to multiply it by the tolerance value, which is 10. So that means that if we've reached maximum speed, the obstacle distance will always be increased by 10. So that would mean that basically the minimum obstacle distance will be 18 and the maximum distance will be 60. And if we have reached half of the maximum, whoops, where is it? If we have reached half of the maximum speed, then we will only add half of the tolerance value. So that should be fine, but I think we also need to factor in the minimum speed. So let's actually do that. So we can't just divide the current speed by the maximum speed. We also have to go ahead here and subtract the initial speed from both values. Like this. So this should be correct. So basically this gives us the progress in percent that we have made towards reaching the maximum speed. So let's see, if we start with a speed of 200, and subtract the start speed, so it'd be 0 here, This would be 600. Yeah, that's correct. That should be correct. So now we have a tolerance value in our target distance calculation that accounts for the current speed of the T-Rex. So this should be fine now, I guess. So at the end of the day, we will have to play with these values a little bit, but let me go into the T-Rex class here. Let's go down into the initialize method here, and I'm gonna start up the game here again. See if this is okay now. Yes. Okay. Now it's here. Generally, I think the speed and the distance between the obstacles is about fine now. You can play with the values yourself and adjust them as you like. Let's see. Let's actually make the T-Rex accelerate as the game progresses. Let's go ahead and create a constant for that. And maybe call it acceleration pixels per second. Actually, basically it's pixels per second per second. Let's say 5 pixels per second. So if 1 second passes, we are up from 280 to 285. After 10 seconds, we would be at 330. After 20 seconds, we would be at 380. Let's call this PPS per second, so that we know that what this is measured in. Acceleration pixels per second per second. Yeah, let's try. Let's go into the update method here, and if I don't know if we only want to increase it while it's running. I guess while it's jumping, it should also increase the speed. So basically, whenever it's not idle. So let's go here and say if state does not equal idle, speed plus equals acceleration pixels per second multiplied by game time, elapsed game time, total seconds, and we need to cast this to, this is not a method, to float. There we go. And we need to make sure that the speed doesn't exceed the maximum speed. So if the speed is greater than max speed, we will just set it back to max speed. And this should be fine. Yeah, let's start it up. Now we should see that the speed slowly increases. And I guess we can actually increase the acceleration a little, because I'm hardly noticing. Oh, actually I do notice a difference. No, I guess it's fine. 3 seems to be fine. I think that was a pretty good guess. Yeah. I mean, I'm happy with it. And again, we can always just adjust these values, play with them. It's fine. Yeah. So now we even implemented the acceleration. So that is dealt with as well. So let's see what we can do next. All right, let me actually open up the game again here really quick, because like I said, we might want to move some of the cacti sprites up a little bit, or like generally move them up. Here, definitely the larger ones are definitely in need of some repositioning. Maybe just 2 more pixels. And maybe this one as well, like this. 80 and 94. Let's have another quick look. Yeah, that looks fine to me, and that looks fine to me as well. Yeah, I'm happy with that. But now let's actually change the draw order. But actually, first of all, let's move these. Let's make these actual constants. So right-click, quick actions, introduce constant. There we go. Let's say this is the larger one, right? Large cactus pos y. And the other one as well. There we go. Small cactus pos y. There we go. Now, the draw order for the obstacle manager itself doesn't matter because it doesn't draw anything. But the actual obstacles, yeah, they're currently always at their default draw order, which is 0. Let's just go into the obstacle manager and define a constant. And call it obstacle draw order. And remember, the entity manager sorts the entities by the draw order in ascending order, and then calls the draw method in that order. So that means the one that is drawn last is on top of the rest of them. So that means the number's gotta be quite high. Let's see what we got for the T-Rex. Maybe let's go into the T-Rex game class, and I think somewhere here, I think we defined it. I think we set it to 10. Yes, we did. So let's set it to, I don't know, let's say 12. Oh, excuse me. There we go. And now here, when we create the obstacles here, we need to actually set the draw order to that value. There we go. And now they should be drawn on top of the T-Rex. Let's see if that works. Yep, perfect. Let's turn this into a constant as well manually. Private constant integer obstacle despawn pos x is -200. There we go. So now it's a little cleaner. And yeah, looks good. So now let's actually make it possible to lose the game. So we need to implement the collision detection, and we actually need to implement the, I think we called it kill method in the T-Rex class. Let's have a look here. T-Rex die, actually we called it die. So we need to implement this die method, and we need to implement collision detection. So let's go ahead and do that. And also what we're going to need to do is add this little game over screen here. So as soon as I run into an obstacle, this game over layover thing should be rendered with a button that lets me restart the game. Yeah, let's take care of that now. And after that we can implement the other obstacle, which is this flying dinosaur, the pterodactyl. But let's just make sure that the actual collision detection works. So yeah, let's see. How can we achieve this? Well, first of all, I guess we should start with the game over screen. Let's do that. Let's implement the game over screen. We haven't actually designed that here in our class diagram, but I guess we don't really need to. Of course, the new game over screen class will be an implementation of the iGame entity interface. It's basically kind of similar to the scoreboard. So it's really just a UI overlay, so to speak. Yeah, that also is just an entity like any other in the game. So let's go ahead, go back into the code, go into the entities folder here, right click, add class, and call it game over screen or something like that. Make it public, even though we don't technically need to. And then I'm going to implement the iGame entity interface and let IntelliSense create some stubs for the actual implementation. Draw order, I guess we can use a hard-coded value here, or not really a hard-coded value, but a constant value, because it will never change and it will always be drawn on top of everything else, I guess. So let's go ahead. What draw order did we specify for the scoreboard? Let me check that again. I think 100 or something. Yeah, 100. So let's go with 100 here as well. So let's just, yeah, I guess it's technically hard coded, but yeah, it doesn't really matter. Let's remove this. We don't want to throw exceptions. The update method, no, I was about to say that the update method would probably not do anything, but that's not true. But let me just go ahead here. First of all, of course, again, we need a reference to the texture so that we can create a sprite in order to render this particular section of the texture, this here, and also, of course, this area right here. Let's see what the coordinates, the texture coordinates for that are. Let's go ahead, let's see. Yeah, this should be fine. So the X position is 655 and the Y position is 13. Let's actually maybe move it down 1 pixel like this. So 655 and 14. Let's define those values as constants. texture quartz pos x, or maybe say game over texture pos x 655, Control D to duplicate, rename it pos y, and what was the value again? 14? Yeah, 14. There we go. And the width and the height, of course, also need to be defined. So let's go back here. Height seems to be 14 and the width is 192. So 192 and 19. 14, whoops, are the values. Game over sprite width, I guess. 192, Control D to duplicate and say height, and rename and change this value to 14. There we go. And that's all right. I guess while we're at it, let's also take care of defining the positioning values for this button here. I guess we can just go with 0, 0 as the coordinates, and we just need to check the width and the height. So width seems to be 39. Maybe let's use 1, 1 as the start position. I guess that's better. Yeah. Yeah. Let's use these values here. There we go. Let's say button texture pos x 1. Texture pos y is also 1. Then button sprite width is 38. Control D, change this to height and change the value to 34. There we go. Yep, got it. Now let's use these values to actually create sprites. And for that we need the texture, so let's go ahead, create a constructor. Type in ctor, double tap, there we go, and pass a texture here and call it sprite sheet. And then we need either a field or property for the 2 sprites that we want to render. Let's go with a field for now. We don't really need to expose it publicly. So let's say text sprite and button sprite. And then here in the constructor, we're going to actually create instances of sprite. So text sprite equals new sprite. Oh, seems like I accidentally used the sprite class from the SharpDX Direct 3D9 namespace. Obviously, that's not what I want, so I'm going to remove this using directive here and actually change this here to a using directive of our own sprite class here, which is T-Rex Runner Graphics. And there we go. Now that's actually referencing the correct class. And here, pass the sprite sheet texture. The X position is game over texture pos X, then game over texture pos Y, game over sprite width, and game over sprite height. There we go. And same thing For the other sprite, button sprite equals new sprite. Pass the sprite sheet and the coordinates. Button texture plus x, button texture plus y, button sprite width, and button sprite height. Seems a bit long. Maybe let's format it like this. And done. Okay, so now we got the two sprites that we want to render, but we also need to position them correctly on the screen. And I guess since they should always be drawn in the center of the screen, maybe. Well, let's leave that responsibility up to the client of the class, which will be our game class. So let's create a property here of type vector2, name it position. There we go. And the position here again will be, the origin will be the upper left corner of this whole game over screen. So we have to kind of work with those values and calculate the correct positioning, but let's see. As with any other graphic in the game, any other sprite and texture, the origin here will always be the upper left corner. And we're going to assume that the position that is the property, the position property also sets the upper left position here of this entire thing. So basically what I need to do, I just need to render the text at the exact position as it was set via the position property. And then here I will need to add a few pixels to the X position and Y position in order to calculate the position of the button. So let's do that. Let's say, maybe let's create a separate property, which will be a private property, also of type vector2, and call it button position. Whoops. And actually, it will only have a getter, so let's implement it as an with an expression body like this, and it will simply return a new vector2 that is calculated using the position plus a new vector, which is, let's see, we need to add half of the size of this game over text here, then subtract half of the size of this button, I mean the width. That will give us the correct X position. And for the Y position, we can just, kind of guess the value. So let's see. So X position would be the current X position plus game over sprite width divided by 2 minus button sprite width divided by 2. In the Y position, let's just say, let's add the height of the game over sprite. Oops. Plus let's say 20. There we go. So now we have basically a helper property that will give us, that will calculate the position for the button sprite for us. So let's use those values here to draw the sprite, or the two sprites. Texture sprite, draw, pass the sprite batch, and the position is simply the position property. Then go ahead and call the draw method of the button sprite. Also pass the sprite batch, and here pass the button position. There we go. I think as far as the rendering goes, we're done. We will also need to implement some update logic for listening to mouse input, so that we can tell if the user pressed the little button. But for now, let's keep it like this. And obviously, the game over screen should not always be visible. We should be able to enable and disable it. So let's maybe add a property here of type Boolean and say is enabled. And by default, this will be false, which is okay. And then here in the draw method, we're going to say if not enabled, return. So if the game over screen is disabled, the draw method will simply do nothing. And let's also go ahead and do the same thing here in the update method, even though it doesn't actually do anything yet, but we're going to add some logic here later. So there we go. Okie dokie. Now, what else? First of all, let's go back into our game class, T-Rex runner game here, and let's add an instance of the game over screen class somewhere. Let's go up to the field declarations here, and let's go maybe here. Private game over screen, and initialize that in the load content method somewhere around maybe here. Game over screen equals new game over screen, and pass the sprite sheet. There. And then add it to the entity manager like this. Simple as that. So yeah, that's it for that. And now what else? Yeah, maybe let's go ahead and create the die method within the T-Rex class. So let's move to the T-Rex class here. There it is, and let's move down here. I'm not sure if we maybe already created the method. I don't think we did. Nope, doesn't seem that way. So let's go all the way down here. Implement a new method, public Boolean die. Let me take a look at the class diagram. Yes, we said it should return a Boolean, and that kind of makes sense because if in its current state it cannot be killed, then die should return false. Okay, so first of all, let's make sure that isAlive is set to false if the die method is called. And at the very end of the method, we're going to return true. But let's first check if it is not alive. So if it's already dead, then we can't kill it. So return false. And what else? Maybe it should reset its state to idle. I guess it doesn't really make a difference, but let's actually set its state to idle. And what else? Oh, right. We need to render a different sprite, which is this one. Let's go with this one. Let's see. Check the coordinates. I guess the width and the height, we already have that. We just need to change the coordinates, which appear to be 1068 maybe. Yeah, let's say 1068. And the width and the height, like I said, should be the same as for the other sprites. So let's go up here into the constant definitions. Private constant integer T-Rex dead sprite pos x equals 1068, and just for good measure y position as well, which is 0. Let's add a field here for that sprite. Dead sprite. And let's initialize that here in the constructor. Dead sprite equals new sprite. Pass the sprite sheet. X position is T-Rex dead sprite pos X. Y position is T-Rex dead sprite pos Y. Width is the I guess we call it default. Yeah, default sprite width and default sprite height. There it is. So create a new instance of sprite, pass those values that we just defined as constants, pass the sprite sheet of course, and that's it. Okay, sorry guys, for some reason during the last recording session my microphone just stopped recording for some reason. So I had about 15 minutes worth of footage without any audio. So I went ahead and I removed all of the code that I had implemented in those 15 minutes, so we can redo that now. Sorry about that. Yeah, whatever. I mean, I'm glad it was just 15 minutes. So yeah, now that we have this dead sprite here, we need to actually render that in the draw method, but only if our T-Rex is not alive. So let's go here into the draw method. And so this is the behavior of the draw method when the T-Rex is alive. So let's go here and say if is alive and move all of this code into that if branch by selecting it, holding Alt, pressing the up arrow key a couple times, and then tab to format it, and there we go. Now we have all this code in this if block. So if the T-Rex is alive, we will just do what we did before, and otherwise we're going to draw the dead sprite using the sprite batch, and we will pass the position of the T-Rex here, and that'll be that. Now let's see. I guess, yeah, what we need to do is actually use that isAlive property. We do set it to false here in the die method, but we actually never set it to true. So let's go in the constructor up here. And somewhere like here, set is alive to true. And we will do the same thing in the initialize method, like this. And another thing we need to do is go back into the die method. And we need to set the speed to 0 when the T-Rex is dead, obviously, because otherwise the ground and the obstacles would keep moving, which, yeah, would be kind of silly. So, yeah, that's that. So I guess that's it. And yeah, now we need to actually take care of the collision detection.